Electronics for all. Be warning. This video for scientific only. Be careful if you try to do it at home. Welcome back. In this tutorial video, we will talk about one of the important circuits at ever. Simple battery level indicator using operation amplifiers. In the modern world, we use batteries in almost every electronic gadget from your handheld mobile phone, digital thermometer, smartwatch to electric vehicles, aeroplanes, satellites, and even robotic rovers used on Mars whose battery lasted around 700 sols Martian days. It is safe to say without the invention of these electrochemical storage devices aka batteries, the world as we know it would not exist. There are many different types of batteries like lead acid, NiCd, lithium-ion, etc. With the advent of technology, we are seeing new batteries invented like Li-air batteries, solid-state lithium batteries, etc. which have higher energy storage capacity and high operating temperature range. In this video, we will learn how to design a simple 12V battery charge level indicator using operation amplifiers. Although the battery level is an ambiguous term, because we can't really measure the charge left in the battery unless we employ complex calculations and measurements using a battery management system. But in simple applications, we do not have the luxury of this method, so we usually employ a simple open circuit voltage based battery level estimation method which works really well for lead acid 12-volt batteries as their discharge curve is almost linear from 13.8 volt to 10.1 volt, which usually are considered its upper and lower extreme limits. Previously we have also built an Arduino-based battery level indicator and a multiple cell voltage monitoring circuit. In this project, we will design and build a 12-volt battery level indicator with the help of a quad comparator operation amplifier based IC LM324, which lets us use 4 operation amplifiers based comparators on a single chip. We will measure the voltage of the battery and compare it against the pre-specified voltage using the LM324 IC and drive the LEDs to display the output we get. Let us jump right into it. LM324 is a quad operation amplifier IC integrated with 4 op-amps powered by a common power supply. The differential input voltage range can be equal to that of the power supply voltage. The default input offset voltage is very low, which is of magnitude 2 mV. The operating temperature ranges from 0°C to 70°C at ambient, whereas the maximum junction temperature can be up to 150°C. Generally, operation amplifiers can perform mathematical operations and can be used in various configurations like amplifier, voltage follower, comparator, etc. So, by employing 4 operation amplifiers in a single IC, you will save space and complexity of the circuit. It can be powered by a single power supply over a wide voltage range of -3 volt to 32 volt, which is more than enough for up to 24 volt battery level testing on this circuit. Now, let's proceed with understanding the working of the circuit. For the sake of simplicity, we can divide the circuit into 2 different parts. Reference voltages section. First, we need to decide which voltage levels we want to measure in the circuit, and you can design your resistor-based potential divider circuit accordingly. In this circuit, Zener diode is a reference which is rated 5.1 volt, 5 watts, so it will regulate the output to 5.1 volt across it. There are 4 picks of 1 k ohm resistance connected across it in series to the GND, so approximately 1.25 volt drop will be there across every resistor, which we will use for making comparisons with the battery voltage. The reference voltages for comparison are approximately 5.1 volt, 3.75 volt, 2.5 volt, and 1.25 volt, as the LM324 can work on a wide range of power supply ranging from -3V to 32V. You don't have to worry about providing any separate power supply to the LM324 IC. So we are directly connected to the battery terminals and power the whole PCB. You can check for voltage levels from min 5.5V to a maximum of 15V by using this circuit. I strongly recommend you add another resistor in series in the potential divider across the Zener and decrease the voltage range of each LED. If you want to increase the voltage testing range from 12V to 24V, as the LM324 is capable of testing up to 24V battery, you just have to change the voltage dividing factor of the voltage divider connected across the battery to make them comparable to voltage levels given by the Zener reference circuit, and also double the resistances connected with the LEDs to safeguard it against the high current flow through them. Hope you enjoyed the tutorial and learned something useful. If you have any questions, leave them in the comment section. Thanks for watching. If you enjoyed this video, please like it, subscribe, and click the bell icon to get new video updates.